Hello, and welcome to the MIT SDM Systems Thinking webinar series. My name is Vin. I'm SDM's Communications Director, and I would like to welcome you to what we think will be a very wonderful webinar presented by an alumnus from our first class, Ron Pepin, who is the former CIO of Otis Elevators in the Americas region. Before we begin, a couple of housekeeping items. If you have any questions for Ron at any time, please use the chat window, which should be over to the right of your screen. As many questions as time allows will be read aloud during the Q&A session for Ron to answer. Please note the Q&A will begin at the conclusion of his presentation. Also, the slides and the recording will be available by April 3rd, 2017. An email link will be sent to all registrants along with the speaker's email address in case you would like to contact him. Also, just a few words of background on the SDM program at MIT. SDM stands for System Design and Management. It's a master's program for mid-career professionals. It's offered jointly by the MIT Sloan School of Management and the MIT School of Engineering. It focuses on integrating the technical, business, and socio-political components of complex challenges using systems thinking. Graduates earn a master's in engineering and management from MIT. This series features research and real-world experience by SDM alum, faculty, students, and industry partners. The series is designed to disseminate information on how to apply systems thinking to complex real-world challenges in virtually any domain. Recordings from prior SDM webinars can be accessed and viewed on demand at sdm.mit.edu. And with that, I'd like to introduce Ron Pepin. Ron, please take it away.
Thank you. Good morning, good afternoon, good evening, depending on where you are. Before we get started, I'd like to talk about present three fun facts. As mentioned, I am a member of the first SDM class, started SDM in 1997. While I know the curriculum has evolved significantly since the time I've left, I believe the topics that I'm going to present today have stood the test of time, and they are relevant to you, and that's my hope in this presentation. Second fun fact is Pat Hale, somebody I know a lot of you are familiar with and know well, was my boss at Otis Elevator when I started the program, and he was my SDM sponsor. So Pat, if you're online today, I'd like to reach out and just say thank you for giving me the opportunity. The third is, and this is interesting, I attended the SDM conference last year. And at the conference, I was talking to a few of my classmates, and I realized when we were talking that, 17 years later, that we still use the tools that we learned at SDM. And I found that fascinating. I found that amazing. And I think there's a story to tell that the topics that we learned at SDM are relevant, and they are important. And my hope is that you will think a little bit differently about what you do tomorrow than what you're doing today from this presentation and from the material that I'm going to present. So starting with the presentation, why is this topic important? We can go to the top line here. We've all seen this data, but there's two things that stand out when you look at this top line. Number one, we're not very good. And more importantly, number two, we're not getting better. That means companies invest a lot of time, a lot of money, and a lot of effort to get better on running projects, and we're not getting better. And what I hope to do today, what I'm going to do today, is just talk about what I've learned that helped me get better on delivering projects. If we look at the next slide, it gets even worse, because large projects are really the projects that transform corporations, transform businesses. And a lot of large projects, a lot of large companies today still use waterfall method. So look in the box, the top box in the waterfall method. 3% of projects, large projects that are run using the waterfall method are successful. That's an amazing fact, and that's a fact that we as an industry, we as a sort of a collective professionals need to change. I also find on the next slide, I find what's interesting, very interesting, is we focus a lot on the project management expertise. We focus a lot on training ourselves to get better at running projects. And what this stat tells us, that doesn't really matter. What matters is all the peripheral factors around a project and what companies have to deal with to actually push a project through and be successful with a project. If we move to the next slide, what's happening also, and we understand what's happening, is we're running out of time. We can no longer tolerate unsuccessful projects, investments that don't produce the desired results. But if we look at it in a very short period of time, the average time a company is going to live on the S&P 500 is going to be about 15 years. The average large project in most corporations or transformational project takes 3 to 5 years. So if those two things coming together, are really a bad combination. A large project success rate of less than 20%, 3% when you're using waterfall in less than 15 years. The good news is in all this, and going off of the Watson quote here, there's a lot of data surrounding the failures, and there's a lot of things we can learn from the data. And I think what I'm going to present, some of the topics I'm going to present, some of the lessons learned, are really what I've learned from failing. And believe me, I've failed a lot in this area of delivering projects, and I think I've learned a lot. And my goal here, to some degree, is to share my learning with you. So if we look at it, the big picture, what I want you to walk away with at the end of this presentation is I'm going to present what I believe are the relevant foundational learnings that helped me succeed and helped me deliver projects that met or exceeded business expectations. I want to motivate you to learn more about the topics, because obviously what I'm going to present today, I can't go deep enough to really drive or change your behavior. So my goal today is to introduce it. If you're not already aware of it, introduce the topic and walk through enough of it to where you say, this is interesting, I think there's something there, I want to learn more. And when you're learning more, we can have a conversation to dig deeper into the detail, because I'm really passionate about the subjects that I'm going to present. And I also hope that going through this presentation, that my 30 years experience of delivering projects and working in the industry, I'm hoping I can share some of the things I've learned and the lessons learned and sort of jumpstart your learning as we go along. 4 foundational SDM learnings that I'm going to present today. And these are the topics that I believe have stood the test of time. I'm going to present the rework cycle and sort of lead into what I call a balanced process workflow. I'm going to talk a little bit about innovation and what drives innovation, some of the things that prevent it. I'm going to talk about what all SDM students learn, and I believe it's still in the curriculum, the principles of system architecture. It's driven. Back in 1997, it certainly was driven into us. We talked a lot about this. Then I'm going to talk about really one of my favorite topics in one of my favorite books, Critical Chain. and the whole concept of the theory of constraints. Moving into the rework cycle, and what I found interesting about this, and I can honestly say what I found interesting about most of the slides I'm going to present, I didn't have to do any research. These topics were topics that I've learned many years ago. And when I sat down to do this presentation, I did them from memory and not from going back and researching what was in there. So I might have drawn this rework cycle a little bit differently than it's been presented before, but this is the way I view it, and this is the way I think. In most projects, if you look in the gray box, and I'm not sure how gray it's showing, but most projects, a typical process, people consider work being done to equal work done, and that's sort of the straight line process in the gray box. You have work to be done, you blend in your staff, your process maturity, your productivity, you go through your quality gate, and you have work done. And most project management techniques sort of measure the work that way. But we all know our work is not perfect, and there's a quality function to our work. So as you go through, there's some work that drops down into the undiscovered rework bucket. My experience, and I've seen it over and over and over again with project managers, we typically ignore that box. It's like it's not there. We know it's there. We should know it's there, but we ignore it. We ignore it because we don't know what it is, and we don't know what it looks like. So I think a modification I've made to this rework cycle, and one of the modifications I've made to my management style, is I focus on that undiscovered rework box. And I actually put resources, put staff, put resources, and put processes around how do we discover what's there a lot quicker. So the rework cycle, from system dynamics, if we look at it, and the lessons learned from the rework cycle, and you need to do a lot more research to understand really what's going on. But if I step back and take a look at the lessons learned, from understanding and using the rework cycle in my work is, the rework cycle is real, and it can't be ignored. It shouldn't be ignored, and it can't be ignored. I've learned also, and we have all heard about the 90% done syndrome. How many projects have you been on that you're 80% done? It takes you 20% of the time to get 80% done. Then you just drag through the last 20% of the work, and it takes you 80% of the time. I believe the rework cycle contributes to that significantly. And the fact that we ignore the undiscovered rework, it drives that 90% done syndrome. I also look at the next three things sort of all together. And it's interesting, what I find interesting is the topics that were presented a number of years ago are coming through in other forms. And what I mean by that is if we look at what's happening in Agile and DevOps, and I'll mention it a couple times today, we see the characteristics of managing the undiscovered rework and the rework cycle. I think it's also very important to look at, measure the root cause analysis of what's landing in the undiscovered rework cycle. And that, driving that back through continuous improvement will drive a better straight line process. I've also spent a lot of time, and I'd like to have conversation with others if you've spent a lot of time trying to figure out how we accelerate learning of what's in the rework, undiscovered rework cycle. So I've worked with teams to try to figure out, we know that undiscovered rework is there. What can we do to discover it faster? And I think that if we discover the undiscovered rework faster, that's going to drive an overall efficiency in the process. Some of the things we've done and we tried using the discovered defects as sort of as the hints to what you're going to find in the undiscovered bucket. In other words, the failures you've had on the top line, the straight line, if you sort of look at them and say, okay, we've had these failures, that's indicating a process problem, what other failures could that have caused? And we've frequently found, using that technique, we've frequently found some of the work, undiscovered rework, we're able to discover it a lot quicker and get it back into the work to be done bucket. The second topic I'd like to discuss is sort of a balanced process, and it goes back to lean. Some of the lean techniques we learned in our operational class at SDM. And what I find fascinating, again, is how this, what we've learned sort of is morphed into other techniques that we're using today. So if you look at the red items that I put on the screen, what does that look like to you? And this was a discovery when I was putting this presentation together. What does it look like to you? To me, it looks like DevOps. And so if we look at number 3, use the pull system to avoid overproduction. And that is involving the users, understanding the users, and having the users, your user base or your market, sort of pull you forward instead of pushing it behind. And if we look at it, some of the other topics, visual controls, level out workflow, in the continuous flow, you look at it and it's sort of the agile development and the agile principles coming through, or are these principles being formed into an agile format? So if we look at this from a DevOps perspective and also from the lean inventory perspective, and this is the way I've looked at development processes in the past. Whether you're doing agile, whether you're doing waterfall, or whatever process you're following in software development, you sort of follow the steps that are outlined here. You go from requirements to adoption. What is frequently missed and needs to be factored into the equation in your process and how you put your process together is that your level of investment, your work in process investment goes up over time. So when you start in requirements, your work in process is minimal. As you go forward, your work in process is a lot greater. So that's the company investment coming through. What I've also measured in the past is that between each one of these steps, you have an inventory component. And I've learned that if you look at where you are on those inventory components, it sort of gives you a hint into where your process is not working efficiently. So again, if we step up and we take a view of the lessons learned, you know, one of the questions that I think we've all faced, everybody who's developed a product, certainly in the software development world, is I have certainly developed software that was never adopted for whatever reason. So the first learning that I've had, and it's difficult to do, but is to try to really understand your users and sort of develop that pull system. In other words, your users need to be pulling you forward, need to be pulling the functionality, need to be pulling you forward. Instead of the development group going to the users and saying, hey, you can use this to do a better job, you can use this to do this. They need to be coming to you and say, can you do this? Can you do this? Can you do this? And when can you do this for me? And I've also found on that topic, and I'm sure we've all found, that the users don't always communicate what they really need. So another technique that we've used successfully over the last couple of years is design test. And it's not necessarily with the final product, but somehow figure out a way to test that what the user is asking you for will actually be adopted. And there's a number of ways to do that, and I'm sure you can think about ways to do it, but from a short-term perspective, you can just change your processes, even though they might be more manual. Change the process to be the new process and put some manual labor behind it to see if you get the benefits from it. And I think on the second item, I think just understanding labor is inventory, and inventory is money, and labor is a valuable asset. And just measure it as you're going through the process on where tasks are. It's sort of the Scrum board concept, but really pay attention to how the aging behind a task. And what I mean by that is you avoid batching of tasks, and we can go back to the waterfall process. And one of the reasons the waterfall process I believe, fails is because it is a batch process. And let's just say you're in a requirements cycle for a month, 2, 3, 4 months. That means the requirement you wrote at the beginning of that cycle goes dormant for 4 months before anybody picks it up and tests it whether it's good. And at that point, it's too late. So if you're looking to create this non-batch continuous process, you need to look at how fast tasks move the process and sort of the tack time off of the back end. The other thing I've learned, and it's one of the most important learnings on creating a balanced process, is you really need to look how you staff a project. And again, I'm from the software development industry, so I'll use that as an example. And before I really started looking at this, we spent a lot of time, a lot of money, and a lot of effort training developers. And we got very good at developing code. So that group, and that's what people wanted to do. That's where the passion was. That's where the cool people are, and that's what people wanted to do. So we're really good at that, and that's where we staffed, and that's where people wanted to be. But we learned when we were looking through the balanced process that requirements were not being fed fast enough to that group. And on the flip side, that group was just overwhelming to the next step, the QA group. And the overall process was running slow, even though our development group was very good. So the process we went through is we actually reallocated people to move into the requirements phase and people to move into the QA phase. And we got to a balanced process and it was just more predictable, more reliable, and in the end, it actually ran faster. So continuing on the story of inspiration for this presentation, at the SDM conference, and there's a few snapshots here, and I trust I'm not violating any copyright laws, but we're standing next to the book rack. At the conference, there's a space where you can buy books. And we noticed that the 6th edition of Eppinger's book was on the shelf. When I was going through SDM, we actually used the 1st edition, but the 6th edition was there, and I was standing with a classmate, Mark Scott, and we were thumbing through it, and what I noticed is going on to the next page, and what I noticed, even though I have not read the material in the book for 15 years, there was at least 4 principles that I had retained after that 15-year period, and I found that amazing. And those 4 principles, out of the 26 or 28, I'm not sure how many were in there, that I recognized. And the reason I recognized them is because they were in my everyday professional life, and I thought about it frequently when we were putting systems together. The first one is no system sort of lives on its own. It's part of a subsystem, or it is a subsystem to another system. So what that means in my world, when I look at it from managing these projects, is when you're putting requirements together, you need to look up, you need to look down, and you need to look to both sides, because you need to understand how what you're doing, what you're architecting will impact the peripheral systems around it. And interesting that, after I saw this and I was putting this presentation together, then I saw what's happening in Washington with the healthcare bill. I don't think they looked up, they looked down, and they looked at both sides, and they really understood when they were putting the bill together the impact it has on other systems around it. And I understand it's big and it's complex, but somehow it has to integrate in. So therefore, this principle, I think, survives on a lot of things we look at in our world. The second principle that jumped out at me was the principle around complexity. And people that work with me know that I always challenge complexity, because complexity is one of the reasons systems fail. And one of the reasons projects fail is because you have this complex requirement you're trying to deliver, and it's just very difficult to do. So in the process of developing requirements and designing a system, you frequently go back to requirements and come back forward to design, and just ask yourself the question, can we make it simpler? Is this overly complex? Can we make it simpler? Can we drive the complexity out of the system? Can we architect it in such a way that it becomes simpler to design, simpler to maintain, and how do we get the complexity out of the system? The third principle that jumps out, and I think anybody that puts systems together, that architects systems, that thinks about systems, understands that the value in the around decomposing the system properly. And one of the principles I use, I don't want to call it a principle, one of the techniques I use is to make sure you're composing a system or decomposing a system to contain the complexity, going back to the other principle, to contain the complexity inside of the subsystem or inside the module. So yeah, so you're going to have to deal with levels of complexity. We all have to deal with level of complexity. But if we can contain that complexity inside the module, others don't have to deal with the complexity. And one way to do that I've learned is look at the traffic on your interfaces and look at the complexity of your interfaces to other subsystems, and you try to slice the system or the subsystems at the point of least amount of traffic. So contain everything in a module. Then when you're communicating elsewhere, try to slice it in such a way that communication is minimal, it's clear, and it's direct. Also, from an architect's perspective, people that have put systems together, and lessons that I've learned because I've lived this case, is look at your system and make sure it can evolve. Understand when you're putting it together, when you're putting the architecture together, understand how the system is going to evolve. Understand what portions of the system will not evolve because they're stable. And then understand what functionality and what portions of the systems are likely to evolve. And make sure you're architecting and designing it to allow those portions that will evolve quickly to evolve quickly, because that's what's really going to sell your system and make sure your system is adding value to the overall process. Now, if we get into innovation, and there's a lot of talk about innovations these days and how you make innovation happen. And I think the last comment or quote I put here from James Utterback is that those who study history and understand the theory can make better predictions. And if we look back, one of the interesting things we learn is just how work done in the past influences work done in the future. In the case that came out of James Utterback's book, one of the cases that was presented in the book, and again, I remembered this, and that's how important the learning was, is and if we look at it, and we look at the light bulbs there, and what do all those light bulbs have in common? We understand that they become more efficient, they give off more light, What's inside the glass is completely different than we've had before. But if we look at what they all have in common, it's that socket. And the socket was first licensed by Thomas Edison in 1909. So this is technology that's almost 100 years old. And all of the light bulb design that we have today is being constrained by that technology that was licensed almost 100 years ago. And I find that fascinating, and I also find it in my world almost every day. And my experience is, and the analogy jumping over into my world and understanding the constraints on innovation in the corporate world, we'll talk about on the next few slides what happens when you have disruptive innovation. But in the corporate world, we're frequently constrained by the legacy systems. And the way I talk about it, and people that work with me understand this, and I talk about the legacy system as an anchor. And what I mean, it's an anchor that you throw over, and you can't ever get too far away from it. And the reason for that is the legacy systems, typically in corporate America, are right at the center of the universe. Everything goes in and out of the legacy system. So when you're trying to innovate, that center of the universe is really hard to move. And it sort of constrains the innovation that you want to put forward. The second is that the legacy systems are very important. They're typically the system of record. And the organization counts on the legacy systems to produce the data that they need to produce to make sure the business is running properly, the business is controlled properly. And there's a lot of people looking at the data, and there's a lot of people that have been trained to look at the data in a certain way. And the third point around legacy systems, and I think we've all seen this, is that the organization reflects the legacy system. And the way people work, the way people think, how we train people, the organization reflects that system. So you come along with a very good thought and saying, I can change that legacy system. I can get rid of that legacy system. We can be so much more effective. We have to understand how difficult that is and how ingrained that legacy system is in the processes that are in place in the corporation. So the lessons learned, and I think I've gone through most of them, but the lessons I've learned, and this is difficult to do, and I don't call myself an expert at it, something I'm still learning how to do, we're still learning how to do effectively, is as quickly as possible, move the center of the universe. We tend to say we're gonna, from a development perspective, we tend to say we're going to keep the legacy system in place, and we're going to innovate around it, and we're going to transform around it. My recommendation is, in most cases, is the first thing you need to do is move the center of the universe, and the legacy system becomes the other system and not the main system. It has to stay there because everything goes in and out of it. But you just change your thinking, you get yourself on the new platform, and I find you can run a lot faster if you do that. So move the universe as quickly as possible. The second is, and I've been burned by this a couple of times, and this is how I learned this lesson, is make sure you structure your future database in the way you want to structure it. And what my lesson learned here is, because everything still had to go back to the legacy system, I found we were designing our data structures to easily translate back into where it had to eventually end up into the legacy system. So what happened was over the project, 3 to 5 years over the project, 2 to 3 years over the project, at the end of the day, you sort of, and this is where I learned this lesson, you sort of looked at what you had and you say, you know what, it looks a lot like the legacy system. And you were still living with some of the constraints, even though you're on the new platform, you're in the new database, you're still living with some of the constraints that were in the legacy system that you want to run off of. And that's because of that connection, that required connection when you're going through the transformation. in the thought process in your head to make it easy to get back to the legacy system. And I think the third item on this list is the item I mentioned on the previous page, and to some degree it's Conway's law, is understand that when you're going through a transformation and when you're taking away the anchor of the legacy system, it's more than the system. It influences the whole enterprise and how the whole enterprise is going to function. And this is really, this concept here, Conway's concept, Conway's law, is really why a lot of our projects fail, is because we don't understand, we don't work, we don't plan for the overall business transformation when we're doing a system transformation. The second topic is around disruptive on innovation, is around disruptive innovation. You know, and I find this fascinating. I read the book while I was going through SDM, and I've never been able to really get it out of my head and sort of drop the concept from my everyday thinking. I think I've bought the book and given it to 20 people because I think it's that important that people in the organization understand this concept. You know, and I think I'm not going to explain the concept, but with disruptive innovations, we frequently see that the disruptive innovation the first time out of the block is not as good as what you have. You know, it addresses, it typically finds a home in a small market, in a niche market. But what the innovation has that is a high slope. It's improving very quickly, and very quickly it's the functionality or the utility is going to pass the functionality in the utility that you have. So some of the things here, we can see why management in the corporate world, you present this disruptive innovation. This doesn't make sense. It doesn't have an ROI. It makes a lot more sense to invest in our current system and just keep putting major enhancements, band-aids on top of our current system, and instead of investing in this risky technology that doesn't offer the benefit. I think the other thing management doesn't like about it, if you do really embrace disruptive innovation, it gets a little worse before you get better. And nobody in the corporate world sort of wants to take a step back before you go forward. Everybody's looking to always go forward. So the net result is your investment continues to flow in your existing products. But what I've learned, the takeaways I've had, and when I try to bring to the table, and I say try because it doesn't always work, but I hope to get better at it the more I try to do it, is try to factor in the slope of the technology improvements in the disruptive technology into your ROI factor. It doesn't fit in directly. It's sort of tacked on to the side. But it has to be in the conversation, and up until a few years ago, it was not in the conversation, not in my conversations. The second bullet here is you really, from a corporate perspective, especially today in today's the disruptive period we're in today with so much technology in the market, you really need to take a step back and just look at what's going on in the world. And say what technology is out there that we could potentially apply to our business to drive the efficiencies or to drive customer satisfaction, and really take a hard look at what's going on around the world and what you can do to bring that technology in, and how mature that technology is, and what is the slope of that technology. And the last bullet here is really a different mindset that's been coming to light over the last couple of years. Is how do you run tests to learn quickly and fail fast and fall forward? We used to go in a back room and sort of innovate in a back room and really think about it. Does it really meet our strategy? Does it really meet our business plans? Can we really get ROI out of it? And that was a paper exercise. I've learned over the last couple of years, the right thing to do is if you see something interesting, get it to a test as quickly as possible. And the test can be a number of things. It doesn't have to be a software package. You just test, test, and learn, test and learn, test and learn, and sort of move forward in that somewhat agile format rather than the waterfall format on innovation. Moving to the last topic I plan to go through, and as I mentioned on the top of this is really my favorite topic, but I'll try to get through it quickly. In what the critical chain drives, different than the typical Microsoft project format, the Gantt chart format, is a very clear understanding of the tasks or the events that will really impact your project. So at the end of the day, if you use this method, you'll understand that an hour saved on the critical chain is an hour saved to the project. And on the flip side, an hour gained in the project is in a task is an hour gained on the back end of a project. So the typical Gantt chart, we've all seen it. You have task 1, you have a buffer in it. Task 2, you have a buffer in task 3, buffer. We all know there's uncertainty in each one of those tasks. I've learned through my study that all tasks are estimated at a 90% certainty level, and I'll leave it at that, and we'll talk about that a little bit later. And I believe the typical process that most project managers follow, Gantt chart encourages unproductive behaviors. The 4 unproductive behaviors it encourages are listed here, and I'll walk through each one of them. Is overestimation, student syndrome, multitasking, and why tasks never finish early. If we look at overestimation and we look at the 90% point on this project and the 90% point on this slope, I should say, in this chart, is the point where the person giving the estimate has believes they have a 90% chance of getting the task done on time. The fun fact here is, and the important fact is, that 90% number is twice as long as a 50% number, and that's a number where you have a 50-50 shot of getting the task done on time. So if somebody came in at 90% at a 10-week task, the 50% number would be a five-week task. To make this even worse, and we've all seen this, the project manager most of the time in overestimation will add some time. And also what you'll see is that once it's presented to management, what I've seen, once it's presented to management, they add some time too. So there's all these factors, the 90%, the PM, and management adding time to the project. So this is how we overestimate projects. You would think, because we overestimate, our numbers, remember the top line back there, the 30% at the beginning of this presentation, we should be pretty good at hitting our dates. We've learned we're not pretty good at hitting our dates. And I'm going to walk through a few reasons why I think we're not pretty good at hitting our dates. And one of the reasons is the student syndrome. And this is what takes buffer out. And I think we've all seen it, but to go quickly through the student syndrome is when we're handed a task and we're doing the estimation, we do a little bit of work, then we do nothing until the point, which some argue, we get to the 50% estimation level. Then there's chaos. Then we work very hard. We try to get it done because we really think we can get it done in the 50% time frame. Then somewhere in the middle of that, Murphy hits. Murphy comes home and something happens. So we always end up late. So the point here is, no matter how much time we allow for a task, the probability of being late is almost exactly the same. The other way we take buffer out of the system, the buffer is the overestimation, is multitasking. And in my world, multitasking is evil. A lot of people think they can do it well. Being an engineer, being an IT guy, I know I don't do it well, so I try to take it out of the system. But the 3 factors in multitasking, there's a large switching cost. Anytime you switch from one task to another task, there's a loss. And some studies say it's 40% of your productive time. The average worker's productive time is lost to the multitasking and switching. Other studies have said it's just less effective, and I think we've all seen this about hand-free mobile phones. You know, it gets us to a 0.08 blood alcohol level. Our ability to react to situations when we're in the car and we're talking on the phone, our ability to actually drive that car goes down significantly. And I think you sort of get this on projects too, that same effect on project. When you're switching, it just takes you a while to become effective. And the last one I thought is most interesting, that people that multitask a lot, even when they're not multitasking and they're focused on a task, they work slower. And it's because your brain to some degree has been, you know, and I'm not an expert on this, but my layman's approach to it, your brain to some degree has all this other stuff in there, and you're not focused, and you just overall slow it down. And the last item is so if we go through the process, the concept behind the critical chain is get all of the tasks to the 50% certainty level. What this drives, looking back at the student syndrome, what this drives is we will start the task earlier. And because we know that the date is coming, we have 50% probability of hitting it. We won't wait around as long to start the task. The second is work to identify the path, the tasks that you have to put together that where if you lose a day on the critical chain, it shows up on the other end. So there's no buffer. Take the buffer out of the task and make sure if you don't hit your date on a task, that it drives a 1 day later on the end of the project. And that's a hard activity to do. So most people will be very anxious about saying, okay, you're going to take me from the 90% level to the 50% level. And how do I do that? You're putting a lot more risk in the project. The way to get around it in the critical chain method is you take all of the buffers that were in the task and you put them at the end. And so all of the tasks can now feed or use that project buffer that's put at the end of the project, and it's sort of a shared buffer. What that means, getting back to task not finishing early. The reason tasks don't finish early, because if you have a task that's supposed to take 2 weeks, even if you finish in a week, you're going to use those other days. Typically, you're going to use those other days to gold plate your design, to do some other things in your design, to write better comments in your code, change it a little bit, and perfect it. By moving to the 50% estimation level, you really don't have time to do that. So you're working off of a process that makes it more likely that you're going to take advantage of early finishes when you actually get something done in 25% of the time. So very quickly, a summary of the tools, the rework cycle and the balanced flow, and how that sort of fits into Agile and DevOps. Understanding disruptive technology and the innovator's dilemma, which means understanding history and understanding challenges between introducing new technology into a system. The principles of system architecture, I presented a couple of them. I think all of them are important, and I think it's a good exercise to go back and study the work that has been done in the book I presented, and really understand the principles behind it. And I would recommend to anybody on the line to pick up a book of the critical chain and understand the methods and the processes behind it, because it has helped me, and it will help you understand how to deliver projects earlier. Thank you.
Ron, thank you very much. That was really excellent. And I'm not sure if you did this or you're able to do this during the Q&A, but if you could please put your contact info up on the slide, that would be great. If not, oh, there it is. Thank you so much. So we are moving into the Q&A section. of the webinar. If you have any questions, please type them directly into the live chat box and I will read them aloud. Getting some paper noise in the background. If you're not Ron, please make sure you're muted. For those of you who have to leave early, just a reminder, I will be sending out a link to the recording and Ron's slides within about a week, and also notification of our next webinar, which will be on April 10th, which is will be presented by Dr. Ellen Cheka, who is an SDM alumnus, and she'll be discussing her research on how a life cycle assessment model can aid sustainability negotiations along the entire length of the supply chain. So our first question is from Hans Greiser. I hope I'm pronouncing that right. Who asks Ron if he can share any experiences using Agile for hardware projects as opposed to software.
Yeah, unfortunately, my career, my entire career has been in the software development space, except very early. First 5 years of my career, I dealt with hardware. But we didn't use Agile then, so unfortunately, I can't share any experiences. I apologize.
Thank you. Folks, we are still inviting questions. Please type them directly into the chat. We'll wait a minute or two and see if there are indeed any questions. Okay, from Brian White. Do you put users into your system intentionally? If not, why not? And there's a couple of other parts to this question. I can reread them if you'd like. The other part is, what about other key stakeholders? That's what makes the situation complex, and you can't throw that out.
Yeah, it's an interesting question, and I'm trying to understand the context behind the question. Do we put users into our system? I'll interpret that as, do we put users into our process? And the answer to that is absolutely, and it gets back to understanding it's all about adoption. We don't develop any product without the intention of it being adopted, and that's why we do it. So if you take that mindset that it's all about adoption, your success is going to be measured by how well your system is adopted. You can't not put the users in the system, in the process. You have to go out. They have to be an integral part of your development process of how you do business, because they are why you do business. So the answer to the question is absolutely. We put the users in the system. It does add complexity, but we have to remember we don't do anything unless we intend it to be adopted by the users.
Okay, Brian also asks, what about other key stakeholders?
Yeah, I think if we go back up to one of the early slides on why project fails, I think looking through that list, projects fail because the other stakeholders are not engaged. The executives are certainly key stakeholders, and we work very hard to keep them informed. And I think if you look through that list, I'm not looking through the list right now, but if you look through that list, you'll see just informing the other stakeholders, bringing in other stakeholders at the appropriate time is absolutely critical to success. And I think that's the message that was on that slide, and I think it was the third or fourth slide about who influences the success of a project. Unfortunately, it's not only the talent of the project manager and the expertise of the project manager. it's all of the other stakeholders and all of the other systems around it. Influent, if you believe that slide, influent from a 95% of the time, and the expertise of the project manager only influences 5% of the time. There's a message there, and the message is you have to include all the stakeholders, your customers, your users, in the design, the requirements design phase to make sure you get it right at the end.
Okay, thank you. From Fred, it looks like Khalil, who says, Ron, thanks for sharing. How do you deal with complexity? How do you measure and manage it?
That's an interesting question. Measuring it is difficult. I'll be transparent. We tried to have hard measurements on it a couple times, and we were never really successful. So the way we deal with it, and I said in the presentation, is we challenge it frequently, and when we challenge it, sort of the trigger to challenge it is when the designers sort of look at it and sort of say, that's hard to do. That's a little bit different. That's hard to do. That's sort of the trigger in my mind. Let's look for a different way. And I know that's a soft answer. That's a soft, unscientific answer. But it's sort of we let the people tell us, the people that have to do the work, tell us that this is complex. This is going to be hard to do. This is not how the system is architected. There's a lot of trigger questions that come in, or trigger comments that come in, and that I've learned over time that said, maybe there's a better way. There's not always a better way, but we always go back and challenge to see if there's a better way. And frequently we're successful. Sometimes we're not successful, but it never goes by. It never goes through the process without a challenge on things that the people that have to design the system think is overly complex and hard to do.
Okay, thank you. I'm going to jump ahead to some folks who haven't answered or questions yet, who haven't had their questions answered yet, excuse me, or who have a comment. First, the comment, which is from Jonathan Allen. And we're not set up to have a discussion during the QA, but he does make the statement that hardware development can be similarly optimized. So what I'm going to invite Jonathan to do is, if he would like to type his email address or other contact info into the chat, people who would like to touch base with him to learn about how hardware development can be similarly optimized will have a way to do that. The second thing is, the next question is from, Manan Kuthuria. How do you limit multitasking in a highly matrixed and agile organization where you've deliberately assigned, when people are deliberately assigned to multiple projects, hopefully based on a backlog?
It's a challenge, and you somewhat, to some degree, you have to get the organization to commit to it. You can't do it in your silo. You can't do it in your group. So it's an organizational thing. It's getting the organization to understand, getting everybody to understand that we will actually produce results faster if you let us do one project at a time. And no group does one project at a time, but subgroups. If you let this team of people do one project at a time and let them finish, then we'll start the next project and let them finish, instead of trying to do all of those projects at once. And because if you try to do all of the projects at once, you have the multitasking effect and everything slows down. But not only do you do it that way, everything that you're doing is delayed. So the value from the project one, for example, is delayed because you're trying to do project two at the same time. And the value of project two is delayed because you're also doing project one. Whereas if you just do project one, get it done, and leave, then do the next project. it actually happens faster, but it's a conversation with the business. Where I find in my world it's most complex to do that is not that people are assigned. I think it's easy from a management perspective to assign a team of people, tell them you're dedicated, this is all you have to do, and you sort of put them on the side and you say, do that. Where the complexity comes in is those people on the project are typically the smartest people in the organization. That's why we have them on the project. They know a lot about the business, so they're completely paying about support issues and drawing the line between project work and support issues. That is a complex line that we still work. We're not perfect at, but we try to draw the line, and we just educate people that this project is important. It has a known ROA. It's important for the organization. Try to leave these people alone so they can do their project in their silo. And when they're done, they'll come out and help with other things in the organization.
Thank you, Ron. Unfortunately, we've run out of time. Marco Martinez had a multiple-part question, and Marco, I'm going to suggest you take note of Ron's email address and contact him directly. I'm sure it will require a longer amount of time than we have now. Thank you, everyone, for the excellent questions. Thank you, Ron, for a spectacular presentation. And I would just like to remind you all, we'll send you a link to the slides and recording within about a week. Next webinar is April 10th. Thank you again, Ron, and thank you, everyone, for joining us.
Thank you.